Turning to slide 70, we will consider transition probabilities influenced by covariate for random intercept, LTA. We have a picture here for 3 time points, and the new feature is an X variable, a covariate, that influences the latent class variables and also, and more importantly, the random intercept factor. X is a individual differences background variable, and therefore it should mainly influence the individual differences variable f here. However, for different groups like poverty and non-poverty, we can expect the latent class proportions to be different, and also the latent class transitions. So we want to investigate whether X has an influence going also this way. We're going to start with a look at the outputs for 2 models. These are outputs 8 and 9, and then we're going to go through a list of fit statistics, log likelihood, and BIC for a variety of models. Turning to output 8, let's take a look at the input instructions. We have the poverty covariate. We have the 4 latent class variables, and we're working with an op seed here that comes from a previous run where we weren't happy with the order of the classes, so we reordered them using op seed and s values. You see the s values command here at the bottom. Again, we have the random intercept factor measured by the 5 indicators at each of the 4 time points and equalities of those loadings, and the factor variance fixed at 1 and the factor mean at 0. Actually, this is then the residual variance of f and the intercept of f in the regression of f on poverty. So this is a new feature. We regress f on poverty, so the mean and variance of f is contributed by poverty. Here we have then the usual lag 1 transition relationships, and we have all of them regressed on poverty here. And you see the usual measurement model specifications, invariant thresholds across time. So this is the main effect model, where we allow all of the 4 latent class variables to be regressed on poverty. Let's see then what happens in this run. First, let's take a look at the warnings and errors, and we see familiar ones that we've seen before. And many of these transition logits are fixed, corresponding to 0 transition probabilities. I'm not going to go through the details of this now, but there is a section at the end of this web talk where I'll go into the error messages in detail to see which ones are meaningful and which can be ignored and which one you should study. Instead, let's take a look at whether or not we got the class ordering correct using the latent class indicator means and probabilities. So it's probabilities in this case because we have binary variables. Category 2 is then you get the item right, so to speak, and that's the low class, low probabilities towards the more advanced items. Whereas this is the middle class, a little bit higher probabilities, and this is the high class with high probabilities throughout except at the last item. So we got that ordered in the way we want to. In this case, we can interpret the model results directly because we have a familiar f by situation here. It's true that the items are binary, so this is really an item response theory type of model. So, but we are familiar with how we interpret loadings, or if you want to look at them in the IRT metric, it would correspond to the discriminations, as we talked about earlier. All of them are significant and positive, implying that f is a factor corresponding to perhaps reading preparedness or overall reading skills. And here we have the central result, F regressed on poverty, negative and significant. Negative meaning that the reading skills are lower for those in poverty, which makes sense. And we see then that the effect is almost 1 standard deviation in the F scale if we take the total variance of F to be approximately 1, which you can get from Tech 4. Now, what you want to focus on here now are the covariate effects on transition probability odds ratios. So you get this heading, odds ratios, effect on poverty. So we get this output for each X variable. In this case, there's only one. And for each transition, C1 to C2, C2 to C3, C3 to C4. And we get, for instance, the value 0.501 up here. So an odds ratio is the ratio of two odds. And what are the two odds? Well, it's the odds of moving from class 1 in fall of kindergarten to class 2 in spring of kindergarten. That odds is only half as big for those in poverty relative to those not in poverty. So 0.501 is the difference in the two odds. So the odds is much lower for those in poverty to move on to class 2. And it's significant because this confidence interval does not include 1. True, there are some bigger than 1 odds ratios, like this, which wouldn't make sense. It's the odds of moving from class 2 to class 3 during kindergarten being higher for those in poverty, but also it's not significant. So it's based on very small frequencies and therefore it can be ignored. Here you have another odds ratio, 0.209, so even bigger difference in the odds of moving on to, in this case, class 3 from class 1 during the first grade. Since we have an X variable, we can also take a look at the calculator here, which is in the Mplus drop-down menu. And we have two options, conditional probabilities for the latent class indicators. We're not interested in that right now. And the conditional probabilities and odds for the latent class variables. And that's what we want to take a look at. And here now we want to assign a value of 1 to this poverty covariate. To take a look at that, and we apply that and shows up as 1 here instead of the default of mean. And then we push OK, and we get condition poverty equals 1 here for a bunch of conditional probabilities for the latent class variables. So let's take a look at, say, the last one from C4 to C3. So here's the first mentioning of C4. C4 given C4 equals 1, 2, and 3, given C3 values 1, 2, 3. So here we condition on all previous latent class variables, but C1 and C2 don't matter. In the lag1 model, C4 is only dependent on C3, not C1, C2. So here are the values 0.288, 0.059, 0.653. This is for the first row in the transition table. This is the second row when C3 equals 2, and this is the last row when C3 equals 3. Now this gets repeated here, C4 equals 1 for C2 equals 2 values as opposed to C2 equals 1, and you see then that is the same, so it's ignorable here. We know that they are the same for lag1 models. So that's one model. And then we can take a look at model output 9, which I have here behind. And the input instructions for that differ. Here we actually have a run with the without the reordering, but it doesn't matter. We're only interested in the log likelihood here. So 160/40, moderate number of random starts. F by, same fashion as before, and F on poverty. And we have the transitions here between the latent classes, the lag1 specified model. And then we have the gist of this. We have C1 on poverty here. And note that we don't have C2 through C4 on poverty, because they are instead included as interactions below here. So for model C1, this is the interaction model. For model C1, we have C1 class-specific C2 on poverty regressions. For each of the 3 C1 classes, we have a different slope for C2 on poverty. Same for model C2, C2 specific C3 on poverty. And for model C3, C3 specific C4 on poverty. So that's the interaction model. And it converges. It has a little bit more difficulty, probably, because of being a much more flexible model. In this case, we're going to see it's not needed. So here you have fewer replicates of the best log likelihood. But it comes to a solution that we can trust and include in our list of log likelihoods and BICs to decide on the model. So in the next segment, we're going to turn to a summary of all of the results here.